And this word um, is the way it looks is the result of a lot of research, analysis. And with that, we were able to synthesize this. This is a synthetically produced script model. And what it does, it visualizes encoded text. So behind it are abstractions. And you can see that this is the same information as it travels the internet. But I'm focusing only on the letter Ra, which supposedly is followed by 4 consecutive superscript letters, namely those: Fatha, superscript Alif, Hamza, and Sukun. But what you see if you test this with a normal font and the most widely used ones, you only see problems. So essentially, the industry standard doesn't function. So this word, so that begs the question, how can there be digital Qurans with this technology? Well, let's test Tanzil.net. They have written a word that can be pronounced in exactly the same way, Fadara'atun, but they changed the spelling. And you can see that if you match it against the original Unicode sequence, they changed or omitted elements. Submission.org, same. Actually, these omit letters. Corpus Coranicum, a well-funded European Science Foundation project. It looks like this, and it also does not match the correct graphemic analysis. This one is interesting because on screen it looks good, but if you select and copy it, you will get an image of a font, another font that doesn't function. And of course, in terms of Unicode, that's nothing, because when you copy, you expect to have text and not image. Then another one, Quran.com, it has the correct construction, but if I copy this, I get a placebo Unicode character, which has nothing to do with the text, and therefore, in terms of Unicode, there's nothing. So against this background, you have to understand that what the Mus'haf Muscat represents. It's a scholarly project, theological, linguistic, and digital dimensions. What's aesthetic about it? Well, we don't do this as art historians, but as linguists. So we try to apply a metaphor from linguistics, and the metaphor is minimal pairs. You try to isolate a special problem by eliminating everything else. And the best way is if you can do this on material that is consistent. Qaisar Hafiz Osman spent his life copying Qurans, and he happens to be a pupil of the man whose hand was the only successful Arabic, was the model for the only successful Arabic metal typeface. So Qaisar Hafiz Osman, pupil of Mustafa Izzat Effendi. Here are 2 pages of 2 different manuscripts, and they are identical on every count. You see, if you copy an element from the right-hand page and paste it on top of the left-hand page, it's an exact match. Every single letter group on this page that looks like the other one is actually identical. This is how precise these people could write. And it is the same number of lines, it's the same text, the same size, the same style. Everything is the same except the width of the page. And to adjust the length of the lines to the width of the page, he uses something in the script. And by making this comparison, you can expose his method. So he either changes ligatures or, so this is the mechanism that you can isolate by applying the method of contrastive analysis. And if you do this often enough, you end up with a fully explicit coverage of everything that the script does. And you can make computer models that reproduce accurately the way of thinking of the average Ottoman calligrapher. That is the method. Now, what does it imply? An example. If you look at an early manuscript, at this word, you cannot read it, and in fact, you cannot transliterate it because you don't know how it sounds. So you need a special technique that I call archigraphemic transliteration. It maintains the lack of information. You can also do that on the new later script. On the left hand side is 7th, 8th century Arabic. On the right hand side is 1,000 years later. And in this manuscript, this is really what you find. I just give two examples. In later manuscripts, they try to add the missing information with diacritics, but they do that without breaking script grammar. And one rule of script grammar is that you cannot elongate in front of a final ye. So by adding all these elements, you get a la'i instead of an ambiguous word that could also have been ile. And this is what it looks like in the manuscript. Now, if you want it to be less stacked, you can add letters, but still every individual letter has a vertical relationship with the attachments. And it's not scripts, but you also find it in early manuscripts. So that is script grammar. Now, theologically or exegetically, you could say, with such little sparse information, with so little information that you cannot even read this, you need help. And again, this is what it looks like in the original manuscript. There is only this information. So in the modern 1924 edition and many others, there is a plethora of additional signs which allow you to read this with great precision. Bi amrihi. But none of that information is in the original. What interests me are the ones that I marked green. These are unusual because the normal relation between a base letter and its attachment is vertical, but here there's a horizontal offset. You can find this only in the Naskh style when it is done in typographical form. You cannot find this in manuscripts in the Naskh style. That is a single horizontal diacritic. You also have double ones because my original example had them. What's happening here is that you have a la'i, which in the Cairo Quran actually is represented in a way that overrules the script rule that you cannot extend in front of a yet. So you have another way of spelling a la'i by putting a miniature alif and a miniature hamza side by side instead of on top of each other. And here is the printed edition. So those are double horizontal diacritics. That is because of theological concerns that people should be able to understand the text. Now, linguistically, you can argue that the early manuscripts are written in a kind of Arabic that only had a glottal stop or hams in initial position and inherited an old method of writing from the Semitic tradition that did not have an expression for vowels. And the long vowels were just beginning to be introduced and often are absent. So there's an inconsistent writing, or in this case of the long a, and there's no provision whatsoever for a glottal stop in this image. And you can see that in the original manuscripts, there's nothing. It's very tight. And if you look at the Cairo edition, it looks like this. Lechati'in. And with all the additional horizontal insertions, you get the precision that you need for the exegesis, that you can understand the text. Lechati'in. However, this introduces a new issue. Because if you elongate, there is a rule in script grammar that you cannot elongate two consecutive letters. It's either this one or this one. But to get this correction or addition realized in the Cairo Quran, they override or break the script grammar. And you can see that this only happens in the printed reproductions of the Naskh script, not in manuscripts. That was all after continuous or connecting letters, but it also happens after disconnecting letters. If you look at the word Ibrahim, it's completed with a miniature alif and a miniature ya. The alif sits between letters and the ya sits between connected letters. There's another example that I can take from the Quran where you have in between disconnected letters and a miniature alif. Now, to refresh your mind, there is here an alif sitting between or connected or disconnected or connected, and you have the other way around, a ya sitting between connected and disconnected letters. So both occur under both conditions, and in each condition they have to behave in totally different ways. So this matches the meaning of the word amphibious. They have two different kinds of contextual behavior depending on where they land. It's like they're walking or swimming. And you are only seeing them here in middle position after continuous and discontinuous letters. Now, what does this mean digitally? Now, first, you have to realize the digital infrastructure. Technically speaking, there are multiple solutions for the same problem. How to put letters on screen. Apple has one. There's one by the Summer Institute for Linguistics. There is the Microsoft Uniscribe engine, and Decotype has made the advanced composition engine. They are all designed to deal with the same thing. It's like a propeller airplane, a glider, and a jet fighter. But they all do the same thing. Now, another aspect of digital infrastructure is mentality. And I'm illustrating it with this word. It starts already, the word uleike. There is a small sign on top of the waw, which does not mean sukun, because sukun mutes a vowel. This one mutes a consonant. It has a different number, and it's not expressed in the system font, in the light blue boxes. If I look at various approaches, the same word, the industry has an approach with minimal effort to get maximum turnover. They don't bother to get it right. Then you have the missionary approach, and literally people who try to spread Christianity in the Islamic world, they are very careful not to make errors. So they implement the Unicode standard to the letter, even when it leads nowhere, like in the blue circles, because the pragmatic approach breaks the rules in order to get the right results whenever they can. And then what I call the scholarly approach is to do a comprehensive, exhaustive work to get it to work correctly under any condition. These are 4 different mindsets and 4 different technologies. Now let's look at that. Then what does that mean for data structure? Well, again, I'm focusing on one particular feature, the amphibious character. It can also occur in initial position. In Old Arabic, the glottal stop only occurred in initial position. It was written with an alif. There was no provision for a long vowel, so yeah is actually written like this. But in the Cairo Quran, it's written with a glottal stop in front, and the alif has the function of long vowel. And in terms of encoding, it means that you have an hamza sitting on its own at the beginning of a word. And if you print that with any technology and any approach to technology, it works. But it's a noun, so you're at liberty to prefix it with the article alif lam. If you do that, you will have a problem if you follow the Unicode instructions. Unless you're pragmatic, you find a way to get it to work. And the problem is that the technology did not anticipate a lam and an alif being separated by a hamza. So the Unicode does have a vague awareness that there can be a horizontal offset for the hamza, but the advice is use a horizontal extender to push it away. If you do that in a lam alif construction, it will not solve it. And if you remove the alif lam again, which you are at liberty to do, it was the article, then it exposes an extender that leads nowhere. So this is static encoding with glyphs, because the industry is focusing on preserving a 5 centuries old metal type technology and does not exploit the completely new conditions created by digital abstractions. You should encode the meaning of the script and not the shapes of the script, the graphemes. Now, glyphs, the shapes of the script, and the whole cult around it is actually a completely obsolete concept. You should focus on the structure and then from there build the models of the script to express the information. Now, let me illustrate this with amphibious characters in final position. Here you have the word shay. It's not in initial, so in the language of the Quran, there was no glottal stop in final position, like in modern spoken Arabic. They added a loose one with an extra letter that did not exist. If you encode it with a hamza, it does not cause any problem. Not in the word shay and not in the word juz. It works perfectly. But if you put the word juz in the adverbial case by adding an alif, there doesn't seem to be a problem. But if you do the analogous thing with the word shay, it breaks up the word shay'an. If you then, this is the problem that was addressed by adding the insertion to carry the superscript hamza. And you can see it works in shay, but not even all the time. And if you then remove the extension on the left, which is just as realistic as removing an article, you see that in the word juz and it exposes a loose extender. So that is the consequence of bad encoding. So from there, I step into the recommendations for Unicode. Get rid of typographic encoding. If there are 2 ways to encode Cheyenne, do it the correct way and not the typographic way. The second recommendation is add a new character class. You have to understand that amphibiousness is a reality. And the best illustration is the superscript nun. It was introduced into the Unicode standard for one single word alone, the word nunji, where there was a nun missing, not on top, but between a nun and the gene. And the function, the behavior of the loose hamza is exactly identical to that little nun. It's there to insert a hamza where there was none in the old text and no provision for it. It sits between letters. And you have also to acknowledge that under certain conditions, amphibiousness is conditional. For instance, this same base shape behaves differently whether the alif, depending on the alif, whether it is preceded by a hamza or not, by fatha or not. So there's a fatha here, and it's the fatha dagger alif combination that should trigger the elongation that breaks the rules, but only that one. So these two together should be the ones that make a dagger alif into an amphibious dagger alif. They both go back to the same base shape, and they produce completely different pronunciations depending on which combination is used. Then, unified typographic doublets. Here is a good example. This is the word yuhyi and yuhyiya. Clearly, there is a yeah missing, and for some reason they consider the final or the penultimate one missing, but it's the same thing that is missing. So it should be one character. It's the same grapheme. And it is supposedly based on the lacking of that yeah in the old manuscripts. But the one that has been introduced breaks open like the other letters, so it doesn't function. In final position, it works nicely, but in non-final position, it breaks open the word. And to mitigate the breaking open of the word, they introduced a superscript one. But like this little noon, it's not superscript, it is horizontally offset. So neither of them solve it, get rid of it, and make sure that the one that remains has the correct behavior, which is amphibious. And so then such observations should be supported by international scholarly communities. Otherwise, the Unicode Consortium will not react. So now the conclusion, coming back to this word, 4 superscript characters, that's the wrong classification. And that's because one of them is a fatha, which triggers the alif to become amphibious. So what you see is one amphibious dagger alif with 2 superscript characters, and it's amphibious because it was preceded by a fatha. And that is because there was, in the old Arabic manuscript, there was no provision for long a, and or very weak provision for long a, and none at all for a glottal stop in non-initial position. And that is why the blue image is the one that survives in the white image. Mus'haf Muscat interesting because it is based on the philosophy that graphemes should be the core of Arabic and not typography. And we can do that independently of the industry because we put the whole typographical machine on the cloud without losing any industry standard behavior. It works on any browser, any operating system, any hardware, and most importantly, it's industry independent because the industry holds computer typography hostage by putting it in the operating system. What is new about our approach? Well, that we focus on graphemes instead of glyphs. We analyze Arabic script in its functionality, and then we make a machine that renders that functionality on screen or on paper. And that is diametrically opposed to what the standard mainstream industry does. And this produces a proper digital infrastructure.